All right, let's try this over. Ran out of time here. All right, give two ways to rewrite 16 using your knowledge of exponents. So 16 is 4 squared, or 2 to the 4th is 16. Give three ways to rewrite 64 using your knowledge of exponents. Well, 64 is 8 squared, or 64 is equal to 4 cubed, or 64 is equal to 2 to the 6th. So use some of your answers from A and B to come up with two solution paths to solve this equation. So if we use powers of 4 here, 16 is 4 squared and 64 is 4 cubed. Then I have 4 squared times 2 to the x plus 1 in the exponent. And over to the right I have 4 cubed times 2 to the x in the exponent. So equating the exponents here and using the distributive property, you get 4x plus 2 is equal to 6x. And then subtract 4x. So 2 is equal to 2x divided by 2x is 1. And then if I use the powers of 2, 16 is 2 to the 4th and 64 is 2 to the 6th. So in the exponent here, 4 times 2x plus 1 and then 6 times 2x. So 8x plus 4 is equal to 12x, and then subtract 8x. 4 is equal to 4x divided by 4. X is equal to 1. So either way, I get the same solution. X is 1. So the next slide is the objectives. Students will be able to conceptually explain the log function. Students will graph and identify key features of the log function. So we're going to take notes and do some practice within here. You should do all this on Desmos slides. I decided to just try something different, just writing on the slides here. It's a hard copy of the Desmos slides, which I also post on the classroom. All right, so the Whatpower function evaluated expression, the first few are done for you. An example, so 2 to what power is 8? It's 2 cubed is 8. You can just write because 2 cubed is 8, then this answer is 3. And then 3 to what power is 9? 3 squared is 9, so that's why the answer is 2 here. And then 6 to what power is 36, so 6 squared is 36. And then the reasoning here is I just change this to an exponential. 2 to what power is 32, so 2 to the 5th is 32. 10 to what power is 1,000? 10 cubed is 1,000. And then 4 to what power is 64? 4 cubed is 64. And then 2 to what power is 64? 2 to the 6th is 64. So the answer is here 3, 2, 2, 5, 3, 3, and 6. And then the next slide says these are a bit trickier here. So 5 to the 0 is 1. And then you can do 1 to some power is equal to 5 because 1 to any power would equal 1. And then 0 to some power is 7. Also no answer because 0 to any power is equal to 0. And here 2 to what power is 1 over 32 is 2 to the negative 5th because 2 to the negative 5th is 1 over 32. And then this is no answer because negative 2 to a power is a negative number. You can't get a positive number here. And then 2 to what power is negative 32? 2 to any power is a positive number. So this can't be negative. So my base has to be greater than 1 in order for the what power to work here. So B has to be greater than 1 and X also has to be greater than 1. So notice when this is a negative, there's no answer. So X also has to be greater than 1. This is a greater than symbol here. And we don't usually put fractional values here either. So this is b is greater than 1 as whole numbers, right? Or integers, same thing here. Well, these could be fractions, so I shouldn't say whole numbers. For b has to be a whole number. X can be a fraction, because here's an example right here where x is a fraction. So, all right, so the Whatpower function is what we call the logarithmic function. It's the inverse of exponential. Y equals, this is read as y equals log base b of x. And the inverse, then the inverse x is equal to b to the y. Or you're changing this ben, you can change it to ben. So base exponent number, that's the ben format. Here's base number exponent, base number exponent. So when you see log, just think of what power. So 2 to what power is 16. This is 2 to the 4th. And then 3 to what power is 81? It's 3 to the 4th. So you can write because 3 to the 4th is equal to 81. And this is 1 because 13 to the 1st is 13. And this is 5 to the 0. Oops. And then 7 to what power is 1? There's no answer to that. Because 7 to any power would be either a fraction or greater than 1. And then 3 to what power is 127? This is 3 to the negative 3. So when the base is 10, we call that the common log. It's what your calculator uses. If there's no base written, it's assumed that the base is 10. So use your Desmos calculator to evaluate the following. So let me go ahead and get the Desmos calculator here. So if I look at the keyboard here, you click on here and then go to the keyboard, go to function, look under miscellaneous here. Here's log. So we're going to do log of 36. It's approximately 1.56. So this is approximately 1.56. And then you're asking yourself, 10 to what power is 10? This is equal to 1. And then 10 to what power is 1? This is 0. And this is impossible. So just to let you know on the calculator, log of 10 and log of 1 and log of -2. So what happens when we do those on the calculator? So functions, log under miscellaneous, log of 10. Whoop. Need to get the 10 inside the parentheses there. Log of 10 is 1. Log of 1. So under miscellaneous, log 1. No, I don't want 11. I want 1. So log of 1 is 0. And then if I tried to do log of -2, I'm going to get an error message there. Log -2. Gives me undefined there. So I can write undefined right here. All right, on slide 8, we want to graph the inverse. So when you do the inverse of 0, 1, that's 1, 0. And then the inverse of 1, 2 is 2, 1. And the inverse of 2, 4 is 4, 2. So got some dots here in the wrong place. So. All right, and then the inverse of -1, 1/2 is 1/2 -1. And then if I connect together the points here, it would look like this here. Try that again. So it's going to go along the y-axis here and then connect together the points. And if I happen to draw the line in y equal x, let me do it with a straight edge tool. Here we go. So the line y equal x is here. Something like that. So this graph, the red graph, I reflected over the line y equal x, I get the blue one. And then the features of the log of 2x, the domain. Get off the straight edge tool here. So it would be x greater than 0 or 0 to infinity. And then the range, all real numbers. Or you can say negative infinity to positive infinity. And then the asymptote here would be x equals 0. I think I missed a slide here. Oh, I didn't finish this here. The asymptote is x equals 0. It goes here. The increasing is 0 to infinity, and this is NA. So they're asking you, how does that compare? Oh, that's slide 9. And then slide 10. If we have y equal 10 to the x, what will the inverse be? Would be log base 10 of x equal y. So 0, 1 becomes 1, 0. And then 1, 10 becomes 10, 1. And this is not, this is a subscript, and this is all on the same line here. And then this is negative 1 and 1/10, so 1/10 negative 1. So if I sketch that graph, it looks something like this here. And then the key features of a log graph, the main is 0 to infinity. The range, negative infinity to positive infinity, are all real numbers. The asymptote, x equals 0. It's the same as 2 to the x there. Well, the asymptote of 2 to the x would be y equals 0. Increasing, so from 0 to infinity, and this is NA. All right, so that's it for those slides.